one of your basic and important skills in algebra is to be able to rewrite an equation or rearrange an equation or a formula or write it in terms of a specific variable. And we'll start with a very straightforward one. Just if, let's say I had x plus y equals 5, and I wanted to write that in terms of x. What I would do is I'm trying to isolate x, so I would subtract y from both sides, and therefore I would get, oops, that's an x equals negative y plus 5. Or I could even write x equals 5 minus y, although we usually like to put our variables first, right? I could take that same equation, x plus y equals 5, and write it in terms of y, or specifically even write it in y equals mx plus b form, right? So now in this case I'm actually trying to move the x away from the y. I want the y all by itself. So I can subtract x from both sides, which leaves me just y on the left, and on the right I end up with negative x plus 5, and that's a line I can actually graph because it's in the right format now for graphing or for putting into your calculator, right? And there are examples of this that could be more complicated, and let's focus initially on how to write these in y equals mx plus b form, okay? Because that's primarily the way in which you're going to be going, although you could be asked to write in terms of x, but let's just deal with writing it in terms of y. So, notice that on the left I have x and y together, and I have a 28 over here, and again I want this to be isolated, so this I need to move away, and I'm going to deal with the adding and subtracting of the 2x before I deal with the 7. So first, I'm going to take away 2x from both sides because it is a positive here, right? And I'm going to rewrite my 7y rather in front, and listing variables first, negative 2x, and it's plus 28 because this is a positive 28 here, right? Now I need y still to be alone. I've done inverse ops of adding and subtracting the 2x. Now I need to multiply divide to isolate the y from the 7 because this in here is multiplication. So I'm going to divide, and here you have to be careful that you divide every single term across the entire equation. Every one gets divided by 7. So 7 divided by 7 cancels to 1, so I end up with just y on the left. That's what I want. And I'm going to keep my fraction, especially if this is y equals mx plus b form, because a fraction is fabulous because this is m, which is slope, and therefore I can graph that, right? And 28 divided by 7, they're both positive, so I'm going to get positive 4, making this my b, or my y-intercept. Let's look at one other example on this page. Let's say we had 3x equals 2y minus 6. And let's suppose, again, I wanted to write this in terms of y, all right? I need to isolate whatever's on the same side with the y. Now notice, even though it's on the right side, I want to deal with what's being added or subtracted first before I deal with the number being multiplied or divided. So the inverse of negative 6, I'm going to add 6 to both sides. And again, these here are not like terms, so 3x plus 6 equals 2y. And again, if this is multiplication, I want to divide to isolate the y. I'm going to divide everything by 2, which means that I have y on the left here equals, I meant to put that in blue ink, but you can write it with the y over here. It's the same thing. 3x, or 3 halves x, and then 6 divided by 2 is 3. Notice in this case I still have a positive 3 here because I've got this positive 6 divided by 2. Do you see that that's the same thing? If I could still have done it this way. 3 halves x plus 6 equals y. And then notice how it's just a matter of rearranging, moving this to the other side of the equation. And that's the same thing as saying if a equals b, then b equals a. You can just do that. So just to recap, what you're trying to do is isolate the variable, the thing that you're trying to write it in terms of. In these cases, we've been talking about isolating y. So we want our answer to be y equals something. How you get there is through inverse operations, which means first you're going to deal with adding and subtracting, right? And then you're going to solve with multiplication and division, and you're doing the inverse. All right, that's second. And finally, in your final answer, notice how when we had 6 over 2 or 28 over 7, we reduced these fractions, right? And we reduced them to whole numbers if possible, or if you get a fraction, you want to keep it as a fraction in your final answer. That's it. Work on some problems from the text like this to help yourself practice.